In this video, we are going to see how to evaluate a difference quotient. Now, difference quotient is given by the formula that you see here, f of x plus h minus f of x all over h, provided h is not equal to 0. Now, what is this? We are not going to explore what it represents. It can be seen as the average rate of change. It is nothing but the change in the y value between 2 points. So for example, if you have one point which is x comma f of x, and if you have another point x plus h comma f of x plus h, then if you're calculating the slope of the line containing these 2 points, then that slope could be given as f of x plus h minus f of x all over x plus h minus x, and this gets cancelled, leaving you with just h in the denominator. Now that is one way of looking at it. You can look at it as the average rate of change. But in this video, we are more concerned with actually just looking at the algebra of simplifying this quotient. Now, in order to do that, let us look at examples of 3 examples here. In the first example, I am going to assume that my f of x is just a simple polynomial function. So let me take an example like so. So this is just a polynomial function, and I'm trying to find the difference quotient. So my goal here is just to evaluate this. That's it. I'm just going to go plug things in and I'm going to find the difference quotient. So you could do this step by step. You can either take f of x plus 8 separately, calculate that, then put it back into the difference quotient formula. You can do that, or you can do it all in one step. So let us see how to do it all in one step. So what is my difference quotient? It is given by this formula, right? So write that down. Then you know now how to evaluate f of x plus h. In order to evaluate f of x plus h, what do I have to do? I will have to replace every x in my original function with x plus h. So this whole thing here is f of x plus h, right? So that's what it is. Then minus, I have f of x. I know what my f of x is. Now this is critical. You want to put your f of x within parentheses because the negative sign has to be distributed. So this is your f of x. Now the formula says all over h. So you don't have to write the f of x plus h in f of x. I just wrote that so that you could see it, right? Okay, so then I'm going to rewrite this. So this is how it is going to look. Your actual second step is going to look like this. Okay, this is what it will look like. Now at this point, I'm just going to do some simple algebraic manipulation to this. So I'm going to square the x plus h. I know that is x squared plus 2xh plus h squared minus this. So for now, I'll just keep it like so. In this next step, I'm going to distribute. So when I distribute, I have negative 2x squared minus 4xh minus 2h squared minus x minus h plus 3, and negative times a negative is a positive, positive, negative all over h. So please make sure that you don't make any mistakes with the sign. Okay. So now let's see what we can cancel out. So this negative 2x squared and positive 2x squared can be cancelled. Is there anything else that we could cancel? The positive x and the negative x can be cancelled. The positive 3 and the negative 3 can be cancelled. And that's about it. So once that happens, now let us look at what we can do with what is left behind. So I'm going to rewrite what is left behind. I have negative 4xh minus 2h squared minus h all over h. So that's it. Those are the only three terms remaining. So what do I see that the numerator has in common? The numerator has h in common. Specifically, it has negative h in common. So I'm going to factor the negative h from the numerator. When I do that, I'm left with 4x plus 2h minus 1 all over h. So I just factored the negative h from the numerator. That left me with 4x plus 2h, plus 1, because I factored the negative h. If you don't want to factor the negative h, that's okay. You can just factor the h, and then you will have negative 4x minus 2h minus 1 within the parentheses. Now, once you factor, that's when I can cancel out this common factor between the numerator and denominator, which is h. So that can be cancelled out. Now, once that goes away, what do I have left behind? All I have left behind is negative 4x plus 2h plus 1. You can leave it like this. If you want to distribute the negative sign, that's up to you. But this is your final answer. So now in the next example, let us look at a function which is like so. Let's say it is 1 over x. Okay. So let's see how we will do the difference quotient here. Now the formula for the difference quotient does not change. It is the same thing. Okay. So here I have to replace my x with x plus h. So I have 1 over x plus h minus f of x is 1 over x all over h. So in this step, all we have done is we have substituted in the function given to you. We have evaluated f of x plus h. You have put that in. You have put the f of x, and then you have set this up. So now this is where your algebra skills need to be sharp, because in the numerator, you want to combine the two fractions into a single fraction. As you can see, the denominator is not a like denominator. X plus h and x have no common factor between them. So how are you going to do that? So your least common denominator in that case is just this. So whenever you have two fractions which does not have anything in common, the product of the two denominators becomes the LCD, right? So that means in order for you to get this first fraction, 1 over x plus h, to this denominator, you have to multiply the numerator and denominator by x. So that's what goes here. And then here you will have to multiply the numerator and denominator with x plus h all over h. Another way to look at this is this. Whenever you have two fractions which do not have a common denominator, then remember the product of these two is your new denominator, and your numerator will be this times this, and in this case minus this times this, and that's what I have done. Okay. So now that we have that, we are going to simplify this. So in the numerator, I'm going to distribute x minus h all over x plus h times x times h. Now, how am I able to write it like this? Just remember, whenever you have fractions like this, something over something all over something else, right? Then what happens if you do the keep, change, flip? Then your new fraction will look like this. So in the future, remember, when you have a fraction in the numerator, just one expression in the denominator, this can be written right away as a over b times c. And that's what I did here. Now at this step, I can cancel out common stuff. this and this goes away. So then my next step is written like this. It is going to be negative h over x plus h times x times h. Now you can see the numerator and denominator has a common factor, and that is h. Now I'm going to cancel this. I'm going to cancel this. Now what happens in the numerator? H divided by h is 1. So that not it's cancelled, but we don't write usually that 1 is the factor remaining, but you have to know that there is a 1. So when there is nothing else, you know that there is a 1 there. So your final answer will be negative 1 over x plus h times x is your answer. Okay. So in the third example, let us look at a radical. So let me assume that the function is 2 times square root of x. Okay. So now I have to find the difference quotient. My formula is still the same. It has not changed. I just have to substitute now. Now in the place of x, I'm going to put x plus h. This original function remains as is all over h. So now how do I simplify this, right? I had to cancel something out. So in order to do that, I'm going to multiply and divide by the conjugate. What is the conjugate? So here I could have factored the 2 out to make things easier. But since I didn't do it, I'll just assume that I didn't do it. But it's still okay. I'm going to multiply with this. So as long as I multiply and divide with the same thing, I'm just multiplying by 1. So I haven't altered anything, right? So then what happens is your numerator is this times this. Now, if you look at this, it is of the form a minus b times a plus b. So that should tell you that there is this identity. When you multiply a minus b times a plus b, you get a squared minus b squared, right? So knowing that, let me see what happens to my expression here. So this a is this, right? So this and this gets multiplied. So 2 times 2 is 4, and square root of x plus h times square root of x plus h is just x plus h. Minus 2 times 2 is 4. Square root of x times square root of x is just x. All over h times 2 times square root of x plus h plus 2 times square root of x. So distribute now 4x plus 4h minus 4x over h times 2 times square root of x plus h plus 2 times square root of x. So again, let's see what can get cancelled. This and this can get cancelled now. And so what is left behind? What is left behind is 4h over h times 2 times this. So now the h and the h can get cancelled away. Now this is the time that I will go ahead and factor the 2 out. I should have done it in the first step. I did not, but that is okay. This is what I have. Now at this point, I can reduce the 4, right? You can simplify it like so. So my final answer will be this. So remember, whenever your function has a radical, you will multiply and divide by the conjugate. And then when you have a fraction, you will make sure that you combine it into a single fraction. And then if you have a polynomial, it's pretty straightforward.